Hello, everybody, and welcome to the Agacad's webinar, Cut Opening, Working with MEP Fittings. My name is Alexandra Sierra, and I'll be today your host. I'm working in Agacad as a BIM application engineer, and as a company, we create applications for Autodesk Revit based on the needs of the world's leading BIM practitioners. And our task is to eliminate your tasks that do not create value. And as a company, we have developed the widest range of true BIM software in the world of Revit professionals, covering such things as wood framing, metal framing solutions, precast concrete design together with reinforcement, and some MEP-related tools. One of those is cut opening, and we'll talk about it today. Today we'll be talking especially about the fittings. This was the newest feature added to our tool. It can create openings for fittings, for full intersection of those or partial. What is the workflow of those? How configurations are applied to the fittings, and also activated feature that users now can copy parameters that they want from MEP and structural elements into the opening families. And at the end of the webinar, we will of course end up with the architectural model with real openings for different elements. And as well as that, in those openings, we'll have some information copied from two categories, MEP and structural elements. Let's not waste time and jump to the model. If it's not your first time in our webinars, you probably have already seen this model. I've shown my previous demonstrations of the cut opening on this one as well. And just to remind the picture from the last webinars, it looked like this. For all the straight elements, openings were inserted, and even when there's a fitting and MEP element goes to the middle of the wall or just touches the wall, previously our tool could always create openings in these situations. So it was not exactly the offset that you would want from the fitting, but it was still an opening. It was joining openings, creating openings for all sorts of straight MEP lines, so that being cable trays, conduits, ducts, pipes, and even beams. But for situations like this one, when there's a fitting, somehow it got into the model, we have it and we just have to deal with it. Previously, there was no way to create opening for such situation. Also, when there would be, again, the T getting in, or like this situation, in this case, when there is elevation change that just somehow got into the model, previously our tool would not create an opening since there are just fittings which go inside actually. And you can see it right now. In my model, there are openings inserted with the previous cut opening version. For the straight elements, I've inserted solid models since this is linked architecture. Solid models, those are joined, but no openings in this case, and no openings in these cases when there's a fitting. Also, case like this. But now all of it is possible. And how to do that? Well, as usual, everything begins with our tools for BIM doc, and you can find cut opening in the doc itself. It'll have an orange icon. From here, you can download the trials, watch the tutorials, read some information about the tool, and as well as that, activate it and use its features. All the comments are available through the Tools for BIM doc. If you open the Create Modify tab, let's say, all the features are here. But I usually demonstrate it by adding it to the toolbar. That means clicking this button, and it will appear under the Create Modify tab, and our tool looks like this. There were no visual changes to it so far. I will close the doc. And just to quickly show the configurations, what was possible before and what was added, I will go into the opening configurations. Here we usually describe what kind of offsets would be needed, for what size of duct, how much offset there should there be top-bottom offset, how we should measure elevation of the opening, should it be from sheared zero level, project zero level, what mark should be created for the opening, additional features as joining openings or not joining openings, users can always choose. if they want to join or not, what should be the distance between the openings before they get joined, and the feature which helped previously to create openings when there were also fittings inside the walls is interference check. And with this feature, even if the duct was only touching, or not duct, in this case duct, but usually pipes, conduits, or cable trays would only touch the wall, if the tick was not placed, our tool would still create an opening, but according to the parameters of the MEP, straight line MEP element. So the fitting was not taken into the consideration. But with the latest update, if you will go to the main settings, you will see their additional configuration, create openings for fittings. In your project, depending on if you want openings for fittings or not, you can always turn it on or off. But in this case, we will be working with it turned on. And as well, I can mention that if you create configurations, you can save them in multiple locations. Would it be on your computer, somewhere on a company server, so multiple users could share those. So when the openings for fittings are created, the same dimensions are applied as they would be applied for the system that they belong to. So if the fitting belongs to the rectangular duct system, its dimensions taken according to this table. So the largest dimension is taken, and if it fits in one of these gaps, then the said cut offset is applied. So it's pretty straightforward. If the duct was 100 on 100 millimeters and the same elbow is used or the same T is used, then the configuration with a cut offset of 20 will be applied. And same goes with all the other systems, except that with the pipes, if with the ducts we have just duct elements, with the pipes we have their separation into different connector types. So that would be fire protection, plumbing, sanitary, hydronic, and all other types. So if those are hydronic types, this configuration will be applied. If sanitary, you can write down different configuration. Now I can close those configurations and delete all the openings in the project. And now going back to the model, probably some of you already know, our tool works on the interference check created by Revit through the Collaborate. Previously, it was needed to do interference between straight lines, so that would be ducts, pipes, or cable trays, and then the model where you want to create openings, in this case architectural, and then going walls, floors, columns, framing, or ceilings. But now it's also when the configurations for fittings are activated, it's needed to do interference check for fittings as well. I have already created this interference check, but all what would be needed to do is click OK, do the interference check, and save it somewhere on your computer with an export button and save it as HTML. After this interference check is created, it's needed to go into the read interference check data, choose that file, and apply configurations with which you would want to create an openings. And again, all the configurations which you have created will be available here. And here you will see if our tool finds any issues with the models, cases where it cannot create openings. Those cases are most common are shown here. One is invalid intersection because of parallel location lines. That would be in case if the MEP element goes alongside the wall and touches the wall. So there is no way to create a perpendicular opening, and the parallel opening would be unnecessary, so our tool doesn't create those. And the second issue is actually for this place where we had duct going up, the elevation change. Our tool just says that for this small duct, it cannot create an opening, but the openings would be created for fittings, and we will have no issues right now with this place. Once we combine those, our tool will give a short table with a short representation of all the interferences. Here we can see that walls with the ducts and all the all those interferences. What is needed to do is save it as XML. I will resave it as MEP fittings 1. And already this file will have information about the openings, and it would be possible both for MEP engineer to insert openings, as well as the architect, if he has our tool, he wouldn't need to create all the configurations. He wouldn't need to do interference checks or read interference check data. It would be possible to just take that file, click on Insert Openings, choose the file itself, and go into the opening insertion. And we will do that from the architectural side today as well. And going to the insertion window, here we can do different filtering to choose which openings exactly we would want to insert and what openings family should be created. So with our tool, there comes two different families, solid and void openings. So the void openings can be inserted into the model where structures are actually present to create real voids. And when structures are linked, we cannot cut linked geometry. So that's why we have kind of opening provisions. So those would be solid openings. And in this case, we'll be creating those solid openings. Here on the left, there will be possibility to do different filtering according to levels, category of intersections. So in this case, we have just walls. If we would have ceilings, floors, columns, and beams, they would be shown here as well. And just to save time, we'll be inserting just for the first level for the walls. Once I click this one, in the table, only the level 1 remains. And we can go to the insertion. One neat trick, if you would need to insert only openings for the specified MEP elements, so not just all of those, but just for the ducts, we could do different filtering according to the parameters which are present here in this table. So those parameters can be chosen from the table. Here's the list of all the parameters which belong to the, in this case, walls, ducts, pipes, cable trays, and conduits. We can add them to the table and later do filtering. For example, pipe types, I have hydronic supply system. Maybe I would want to insert openings only for the specific system. So I could do either filter based on the data or distinct values in column. And I see all the values which are in this column. So if I choose hydronic return, apply filter, that means I will insert openings only for the hydronic return system. To remove all filters, there's a button, remove filters, and we're back to level 1. Now let's insert all of the openings. 94 of those, and some of those will be joined, so at the end we'll end up with approximately 20 less openings. And it'll just take a little bit of time to join those, but after those are joined, and we modify them as we need as an MEP engineers, we could extract information about those openings and send it again as a same XML file to the architect. Really, that's the thing that we will be doing. Openings are inserted, some of those are joined. We can click OK. And in this list now we have list of created openings and list of not created openings. If we would want to, in the second step, go into the further creation, we can always do that. But now, if we go into the model, we will see that the openings got a little bit larger. So for this opening, the cut offset was set up to be 20 for this size of the ducts. So we can see that this offset will be now 20 according to the most outer point of the bend. Same thing would work for this element, the transition. But since opening for it was created and it was close to other openings, according to configurations, those got joined. And we can see that now all the openings are created as well for the entrances into the rooms for the cable tray. And those are, again, with the offset, which was described in configuration. In this case, it was, I should take more carefully, 25 millimeters. Doesn't matter the geometry itself, the opening will be always with the correct offsets, and you will not have to worry about this part of the project. And as you can see, for this elevation change, the opening was created as well, but it was joined with other openings. And we can go check the situation again. Just a big opening joined for all of those elements. If you wouldn't want to have one big opening and you would want to look how separately those openings look like, we always have join on join button, which separates openings into the models as they were before the joining. So we can see that two openings were created here, one here, and two openings were created here, actually because we have here two fittings, one inserting from the bottom and one going from the top. And I will go back to join this opening. So all the other features of our tool applies to the openings. If you would want to change the sizes of elements, move them or delete them, upon clicking the opening revision, our tool can check the model, check if any changes have happened, would those be size or location, and suggest to move or change the openings. So no changes were made, we have just one graph, but if I change, let's say, the fitting and the duct size from 100 to 150, it already doesn't fit into the opening. If we do opening revision, here were two openings actually created inserted. One was for duct, another was for fitting. So one will be deleted and the second one will be expanded to fit the duct. It'll be under unjoin because the first function our tool will have to do is unjoin those two. And if I go here, agree with last changes, and you'll see that the opening again fits all the fitting. So no issues in this case. When some changes were made, also our families have parameters such as approved, declined. You can go through the model, check all the elements, and write them down as approved, put a tick on approved, declined, write some comments. And when this is done, it would be needed to transfer this information to the architect to export created, and we will save them as exported. So the architect will not have to go through all the struggle of creating the rules and interference checks. So now, if everything is exported, we can close this model and go into the architectural one. And there we'll insert already the void openings. Here's the model. Let's go into the level 1 3D view. No openings as of right now. Going to the created, exported, and already in the exported file we will have only openings for the first floor because we haven't been creating for the other floors, so only level 1. And we can choose now to insert void openings. Clicking OK. And here's already information about the joined openings, so the tool will not need to go through all the joining processes. It'll take a little bit faster to insert all of those. And here we have all of the cut geometry. Even with the changes that we've made for this fitting, the inserted model was not updated, but since we've exported openings as with the last revision, this opening is bigger than this elbow. And now another feature that was activated for the tool. You will probably know that our tool previously and right now it is copying information about the elements. So it copies system classification, type, name of the system. as well as it copies the service type for the electrical elements. So it was done automatically, it was hard-coded into the tool, but now we have added the possibility to copy any parameter from the structures and from the MEP as the users would wish. And in this project, in architectural, I have some walls which have no fire rating parameter, and we would want to know if the opening should have fire rating or no. So some walls don't have fire rating, and other walls do have fire rating. So let's say we want to copy that information, and then let's say we would want to copy from the fittings or some elements Omni class number. Again, maybe for future scheduling of openings or tagging or anything like that, just useful information. And it just will go to show that our tool can copy not only instance parameters, which are actually easier to copy, but as well as that type parameters of elements. So to copy any of those parameters, we would need to create additional parameters in the openings themselves. And for these openings, fire rating parameter was already created as an example, and it copied value, but Omni class number was not copied. And how to do that? Let's go into opening modification, add one quick modification, and reinsert the openings. So just to show, to copy any parameter from the structural element, it would be needed to create a parameter on the construction category with a single hashtag sign, and then writing the parameter name that you want to copy. For the fire rating, it's very simple. It should be hashtag fire rating. It should be inside the opening as an instance parameter because it changes from one instance to another. And then it's very simple, as fire rating is text parameter, discipline common, type of the parameter text, and it should be created under the construction category to copy from structural elements. If we would want to copy some other parameters, such as length of the wall or volume, we would have to change type of the parameter to correspond to the parameter that we want to copy. And now going to copy Omni class number, let's create the parameter which should drive that. So to copy from the MEP element, it would be needed to create parameter with a double hashtag, and that is Omni class number parameter. Again, instance, and again, pretty simple, text parameter. This one should be saved to copy from the MEP under the model properties category. Just to double check, Omni class number, all seems good. We have this one created, applied, okay. And before rewriting the families, I will delete openings, since anyway those would have to be reinserted to run the copy feature. And now I will load it into the architectural project. It is reloaded. We can go quickly into the exported and insert all the same openings, except with the difference that now if it finds any Omni class value, it will be copied into the opening. Okay, we have 50 of those. All are inserted, no need of new ones. And this fittings had Omni class number of, well, 301717. And inside the opening, under the double hashtag value, we will have that number. So this could be, like I said, any of the other parameters. And now, when going into opening revision, we could find out which exactly openings belong to the cable tray fittings, the specific fittings. This can be done by the table, where it's possible to add any of the parameters. So as I've told before about the approved and declined parameter, we could do Omni class parameter and filter by the values. It will show that some changes should be made because we didn't load a new MEP file, so we suggest to unjoin that openings that we have resized. But we can go into created openings, and in the columns, just from all the rest parameters of the opening, add omni-class number. So either do filtering by clicking on this column to go from top to bottom, or click on the value and do distinct values in column. And if we click on that number, we will have filtered the table, and we see now only the openings for the cable trays. So if I select them, you will see that they got selected in the model. And I can do some modifications, let's say approve them, or decline, or write some other information, as well as change cut offset and do other modifications. So as you see, with the cut opening, it's possible to do more than just opening insertion, but as well as that, the opening control. It would be from presentation. Other than that, I would want to mention that for our tools, we have free trials of 14 days. You can activate those through our tools for bin doc with all the functionality open. And if you have any questions regarding the tool during the trial or after that, you can always contact us via the email support@agacad.com. Thank you everybody for attending, and have a nice day.
Agacad, building BIM together.